This is Form A of the K quiz on waves. So if you are following along, you are looking for this diagram. It is number 1 on Form A. If you do not have Form A, you're going to need to, again, find that picture so that you can follow along with me. It says, what is the amplitude of the wave below? So to answer this, you obviously need to know what the word amplitude is referring to. Amplitude is going to be your maximum displacement from equilibrium for the particles in the medium. In this transverse wave, the particles of your medium are vibrating up and down. And so your amplitude ends up being 1/2 the height of the displacement. This is the total height from the crest to the trough, up and down. You want half of this because, again, your amplitude isn't the whole distance, but rather this distance here, the maximum displacement from equilibrium. So it ends up being half of 1.2, which is 0.6 meters. So the answer to this question should have been A. Let's go ahead and look and see how you guys did on this particular question. As a campus, it was 84% correct. For my classes, 84%. So we're right on the average for this one. Number 2 on Form A is about 2 children playing jump rope. So you're looking for this image right here. And it says, while playing, 2 children create a standing wave and a rope as shown below. A third child participates by jumping the rope. What is this standing wave's wavelength? So if you look at the standing wave here, again, you have this oscillation up and down. But this is actually the fundamental frequency. It's actually only half of the wave. If you can imagine the other half of it, and again, it's not here, but the full wave, I don't know if I drew that to scale or not, but it looks like that. Okay, if you're following this one, or if you're following this one, like that. And so when you're looking at just this, you're looking at just half of the wavelength. And so this is 4.3 meters, but that's half the wave. So if I asked you for the wavelength of this wave, and all you see is, well, half of it's 4.3, then the whole wave is obviously twice as long. And so this one you would want to do 4.3 times 2. And so that, of course, is going to give you 8.60. The answer to number 2 should be D. You guys had some trouble with this one. Only 55% of you got it correct. The campus average was 57%, so you're in that ballpark. But this one you guys did miss. We did talk about standing waves on Wednesday, and we said that first harmonic, or your fundamental frequency, was actually only half of a wave, and so it's actually only half of a wavelength. And so if this is half of a wavelength, then your whole wave will be twice that. So this should be D. Number 3 says the diagram below represents a transverse wave. The wavelength of the wave is equal to the distance between points, and so here you're just looking for wavelength. So A to G is here to here. That is actually 1.5 waves, so it can't be that one. C to G, these 2 points, that is a wavelength because you have C going through the wave in phase at point G. You're back to where you started through one full wave cycle. Let's go ahead and look at the other ones. C to E is actually only half of a wave, and D to F is nothing. I guess it's showing you the total displacement, I guess, but that's obviously not your answer. So number 3 should be B, C, and G. As a campus, this was 90%. For my classes, it was 97%, so you guys did awesome on that. Number 4 says an ocean wave enters a new medium of shallow water at a sandbar as it moves towards the shore. As it propagates from a deep water medium to a shallow water medium, the wave slows down and bends towards shore. What causes this? This is actually the same example that I gave in class whenever we looked at this particular wave behavior. Whenever you have these waves that are approaching at an angle and then they end up bending like this, okay, this is kind of how it looked in class. We talked about how when you go from one medium to another, if that's my boundary, I guess, that you have this bending due to the change in velocity. That is refraction. This one you guys had some difficulty with. Some of you mixed up refraction and diffraction. But again, if you go into the new medium, if you cross the boundary into the medium, that's refraction. Diffraction would be if you go around, like around the obstacle or through it, like through an opening in it, rather than into it. Okay, so like diffraction would be through a doorway, so rather than going through the wall, through the door, and bending around obstacles. This is going into the new medium, and it bends because it changes velocity. 68% of you got this right. The campus average was only 52%, so you guys did better than the average, but of course you're going to see this again. The question on your test is very similar. I believe it has a picture kind of similar to this. So again, that's the scenario that I used in class. Okay, number 5 says the diagram below represents a transverse wave traveling to the right through a medium. Point H represents a particle in the medium. In which direction will particle H move in the next instant of time? I had a slide very similar to this in my notes, and I said you were going to see this again. And so with this one, again, these particles are oscillating up and down, but you need to think of it not as like following this path, because the particle doesn't do that. The particle oscillates up and down. The wave moves kind of through it, and it will trace the line as it does so. So in the next instant of time, this particle is not going down, it's going up, because if you can imagine this wave propagating, if you look at like where it would be in the next instant of time, I don't know if I can draw this to scale, but it would be like over here. And so particle H, if you're at like this position, okay, is going to be higher, okay, than it was before. It's going up, because again, this is just oscillating up and down along this kind of vertical axis, if you will. I have that animation in my notes as well, but again, it's not riding this like a roller coaster, okay? It is oscillating, and so if you imagine where that peak would be, it's going to be forward. So the higher point's going to be forward, this lower point's going to be forward, this is going to end up here. So again, number 5 as a campus was only 46%. For my classes, number 5 was 69%. So again, significantly better than the average, but definitely something that you're going to want to look at, and I do know that this is in my notes somewhere. Number 6 on Form A, you're looking for these diagrams. It says, which diagram best represents the shape and direction of a series of waves after they have passed through a small opening in a barrier? I will say this, I'm not a huge fan of the way this is formatted. Those are where your answers are. A is here, C is here, B is here, D is here. I know some of you may have looked at this and thought this was C. Perhaps it's not. You need to make sure you read it carefully. The other thing is these arrowheads are not super clear. You can see these okay, but these are over here on this end. Obviously they're not on the other end. Nobody asked me about it, so I don't know if that was an issue or not, but I just wanted to mention that. But again, this is picturing diffraction. Okay, whenever you have these waves bending through an opening, again, they're not going through the new medium, but rather in between it. They're staying in the same medium, but through an opening and spreading on the other side. It should be answer choice D for number 6. And for my classes, 76% of you got that right. The campus total for number 6 was 73. So again, slightly above that average. Number 7 is this diagram right here, and it says what is the speed of the wave below if its period is 0.75 seconds. And so if we're looking for speed, again, that's going to be velocity. The equation we have for that is velocity is frequency times wavelength. It's supposed to be multiplication sign, sorry. And so I can get frequency from period. So if my period is 0.75 seconds, that means that my frequency is the inverse of that, 1 over 0.75, and I can get that. And then my wavelength I'm going to get from the diagram. So again, 1 divided by 0.75 gives me 1.33. That would be my frequency. And then my wavelength from here, again, starting at this point and going in phase, my wave ends right here. So my wavelength is 3. And so that would be what I multiply, frequency times wavelength. And I get 4. So the answer here should be B, 4 centimeters per second. Again, this is number 7 on Form A. My class is 66.4, no, that's not me, that's the campus. 66.4% got that right. For my classes, it was 70, oh no, I'm looking at the wrong one, 69%. So slightly above that average. Number 8 says a mechanical wave's energy is determined by its, and you're filling in the blank here. We talked about this. Energy is directly proportional. Sorry, that proportionality symbol looks kind of weird. to amplitude squared. Try that again. Can't draw that today. All right. So energy is directly proportional to amplitude squared. The energy of a mechanical wave is determined by its amplitude. For you guys, that was 86% that got it right. For the campus, number 8 was 66%. So again, well above the average for that one. You guys did a good job. Number 9 says a longitudinal wave passes through a uniform material medium from left to right as shown in the diagram below. Which diagram best represents the vibration, the direction of vibration of the medium's particles? So this is longitudinal. The particles in the medium of a longitudinal wave vibrate in a direction parallel to the direction of propagation, which means all of these particles are along this axis here. They're going to be moving back and forth. It's a compression wave, so you have them move into areas of compression and then they move away, and you have areas of rarefaction. And so this is going to be B for number 9. That would be the direction that the particles of the medium move. 78% of the campus overall got that right. For us, number 9 was 81%. So again, just slightly above the average. Good job, guys. Number 10 says the diagram below shows a standing wave. Again, you're looking for this diagram. Point A on the standing wave is, okay, so point A, these points here are the ones that remain stationary the entire time. All of those points, here, 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 and here. And these are called nodes. And nodes are going to be formed whenever everything cancels out. That's why they're stationary. And so they are formed from destructive interference. The answer to number 10 should be B. My classes, 74% of you guys got that right. As a campus, that was 64%, so it is above the average. It was a little low, so you guys might just want to study your standing waves. Nodes, these by the way are antinodes. Your antinodes are made from constructive interference. Number 11 says in the picture below, section X is called A. Section X is this portion right here where it's all spread out. In a longitudinal wave, you have areas of compression, which would be this or this if those were labeled. And then you have these areas where you have minimum density, and they are called rarefactions. And so the answer to number 11 should have been C. As a campus, 72% got that correct. For my classes, number 11, 81%. So again, that was pretty good for you guys. Not sure what you put if you didn't put that, but again, it should be rarefaction. Numbers 12, 13, and 14 all go with this diagram. It says the string below is 5 meters long and vibrates at its 4th harmonic. The string vibrates up and down with 48 vibrational cycles in 20 seconds. So they're giving you information here, cycles per second, that you can use to find your frequency. And that'll give you a number in hertz, which is the first question. What is the wave's frequency? Again, frequency is cycles per second. So 48 divided by 20 is what you'll do to get that. And that is 2.4, and your unit is hertz. So the answer to 12 should be A. You guys, every single one of you got it right. Awesome job. Nobody missed that in any of my classes. The campus average was also a 98%. The wave period, again, period is the inverse. So if my frequency is 2.4, then my period is 1 divided by 2.4, which is 0.416 repeating. Your unit for period is seconds. This should be C. Number 13, as a campus, 89% got it correct. For my classes, number 13 was 94%. Number 14 says, what is the wave's wavelength? You have the length of this entire thing, but this is not one wave. If you count the wave cycles here, that's one wave, that's 2 waves. So 2 waves is 5 meters, which means one wave is 5 divided by 2. Each of them is 2.5 meters long. So number 14, your wavelength should be 2.5 meters. Number 14, 82% of you got that right in my classes. As a campus, it was 75%. So again, we're a little above the average, but we want it to be a little higher than that. Number 15, again, you're looking for this diagram. The diagram below represents 2 waves of equal amplitude and frequency approaching point P as they move through the same medium. As the 2 waves pass each other, the medium at point P will. If you look at these 2 waves, they are exactly opposite of each other. they are going to completely cancel each other out, and you are going to have destructive interference the entire time. And so this point is going to remain stationary. Okay, if this had been, again, ignoring this right here, if it had been this, imagine that's to scale, if that's what was approaching instead, then this would be adding with this, and this would be adding with this, but we don't have that. That would have been constructive interference, but with what we actually have, those are going to be canceling each other out. That's going to be destructive interference, and it's not going to move at all. So number 15 should be D as a campus, 70%, got that correct for my classes. Where did that go? Number 15 for my classes, only 63%, so you guys did miss this one more than the average. That require a medium for transmission. That's just the definition of a mechanical wave. Specifically, sound is longitudinal, so if you see that thrown in there too, you'd want to pick longitudinal as opposed to transverse. For number 16, the percent correct on this was 87% for my classes. For the campus, number 16 was 79%, so you guys did really well on that one. But again, it should be D. Number 17 says the diagram below represents a periodic wave. Which 2 points on the wave are out of phase? So you need to remember what out of phase or in phase is referring to. So in phase refers to when the points are in the same place on the wave and the wave is doing the same thing. The particles are moving in the same way. And so if you look at this, like A and C, for example, are in phase with one another. That is one full wavelength. Because at this position on the wave, your particle is moving in the exact same way that it would be here. I don't know which way this wave is propagating, so I couldn't tell you if it's moving up or down, but they're on the same point on the uphill side, if you will, of the wave. And again, both of them at equilibrium. So it's not this, those are in phase. B versus F, same thing. They're both on the same portion of the wave, so they would be doing the same thing. Both of them are on, I guess, the downhill side, if you will, and both of them are at equilibrium. They're in phase. C versus E, those also appear to be in phase. Same point, same thing happening, which leaves us with D and G. And if you look at D and G, although both of them are at equilibrium, they are not doing the same thing because they're not in the same position on the wave at those 2 points. They'd be doing opposite things there. So your answer to this one for being out of phase would be answer choice D, which is points D and G. For number 17 as a campus, it was 79% correct. For my classes, Darwin, number 17 was 82% correct. So again, just slightly above the average, something you might want to look at. Number 18 says Carla yells across a canyon. The sound wave she emits travels at 0.343 kilometers per second. If the frequency of the sound is 183 hertz, what is the wavelength of the wave? So again, we are looking for wavelength, and in the question we have velocity and we have frequency. And so with that, if I'm trying to find wavelength, I'm going to be using this equation, V equals F times lambda. And I'm going to plug into it. The problem is I am not going to want kilometers in my answer here because all of my answer choices are in meters, except for that one, which probably isn't right unless I have the wrong unit in there. But kilometers, we need to convert this into meters. There are 1,000 meters in a kilometer. So we're just going to multiply this number by 1,000, and we're going to get 343 meters per second. Okay, and so if we plug into the equation, we'd have 343 equals my frequency 183 hertz times the wavelength. And if I want to solve for lambda, I need to isolate the variable, which means I need to divide both sides by 183. 343 divided by 183 gives me 1.87 So my wavelength of this wave would be 1.87 meters. Answer choice C for number 18. For my classes, 86% of you guys got that one right. For the campus, number 18, 83% got it right. So just around the same number. Number 19, again, you're looking for this image. This is Form A. It says the diagram below shows two waves traveling towards each other at equal speed in a uniform medium. When both waves are in the region between points A and B, they will undergo. So when these are superimposed, when they overlap, and again, if you look at this, these waves, you have crests that are going to line up with crests. You have troughs that are going to line up with troughs. And so when these overlap, this is going to add with this, and it's going to be even lower. This is going to add with this, and it's going to be even higher. You're going to have constructive interference because they are going to overlap perfectly, crest with crest and trough with trough. The answer to number 19 should be D. As a campus, 79% got it correct. For my classes, number 19, 79%. So we did exactly what the average was on this one. Number 20 says, while sitting in a boat, a fisherman observes that two complete waves pass by his position every 4 seconds. What is the period of the wave? So again, period is going to be the time it takes for one wave. So if you have a total time and you have a number of waves, you can divide and figure out how long it takes for one wave. And so it says two waves pass by every 4 seconds. So it'd be 4 over 2. Which of course would give you each wave would be 2 seconds long in that scenario. So the answer to number 20 should be B. 90% of my classes got that correct. As a campus for number 20, it was 87%. So it was not a question most people had trouble with. But again, if you have it backwards, if you're doing the opposite thing, you're finding period. Please make sure you know the difference between the two. Number 21 says the diagram below represents a transverse wave. The distance between points blank and blank identifies the wave's amplitude. So again, amplitude is going to be 1/2 the vibrational height or length. In this case, my particles are vibrating up and down because this one is transverse, so my vibration is going to be perpendicular to my propagation. And so my amplitude is not the entire height, it's not this, but rather half of it, because you're just looking for maximum displacement from equilibrium. So that would be an amplitude. That would also be amplitude. If I look at the answer choices, A and B, no, that's just half the wavelength. A and C, that's one wavelength. A and E, that's an amplitude right there. But let's just check D and E. No, that's the whole height of the wave. So A and E would be what you would want to pick for this one. That is the amplitude of your wave. It is 1/2 the vibrational height, and it is the maximum displacement from equilibrium. Number 22, you are standing behind the moving police car which has its siren blaring. How does the pitch of the sound that you hear compare to the pitch of the sound the policeman driving the car hears? So you are this person over here, and it's asking how your pitch compares to what the actual pitch is, because if he's in the car, he's moving with it, then he's not moving with respect to the sound, so it's going to sound normal to him. But for you, these sound waves, he is driving away from them, and so as he is producing the waves, he is moving away from them, and so the waves end up being elongated, the wavelengths are longer, and that's going to make the frequency lower. Because you have longer wavelengths, you're going to have lower frequency. There are fewer of them per second. And if lower frequency is going to sound as a lower pitch. And so what you hear, it almost looks like the answer is pointing at that, but what you hear would be lower than the actual sound that the siren would be making. For number 22, as a campus, 81% of students got that question right. For my classes, for number 22, it was about the same, 80%, a little lower. Number 23, the pitch of a sound is determined by. Again, I just mentioned this here, but your pitch will be determined by the frequency of the wave. That's just something you need to remember. It's just a memorization thing, so just study that. But pitch is determined by frequency. Amplitude is going to determine volume. How loud the sound is will be amplitude, but pitch, you're going to want to pick frequency for that one. 82% of you guys got that correct in my classes, 82.3. As a campus, it was 80.6. So again, just slightly above the average, but not something that most people struggled with. In addition to the questions that you see in here, your test is also going to include some questions on resonance. Okay, so make sure that you look at that. That was the demonstration that I did in class the other day with the tuning forks, or the video that I showed you with the wine glass, where if you match the exact natural frequency of an object, you can use sound to make that object vibrate. With a wine glass, you can use your voice or a speaker if you match the frequency of the glass, and those sound waves can make that wine glass vibrate and eventually break. With the tuning fork, if you have them next to each other, striking one of them can cause the other one to vibrate. Again, they have to be exactly the same frequency. I also showed you those two xylophone keys in class that were just 1 hertz apart, and they did not do the same thing because you don't get resonance unless you match the exact natural frequency of the object. But you're going to have some questions on your test about resonance in addition to what was already covered in this quiz. You are also going to have some questions about, I showed you in my notes some diagrams that looked, you had waves in there. I don't know, just drawing some. Pretend that looks like a wave. But where I asked, like, which of these is, the loudest and the highest pitch or whatever. Okay, and you had to look at it and look at the both the total amplitude of the wave. Again, the amplitude is half that height, but the height basically, and look at the frequency to determine that. So again, as a reminder, your amplitude is your volume. So if I'm asking for a louder wave, you want it to be taller. And your pitch is your frequency. So your frequency is your pitch. And so if you want a higher pitch, you're going to have a higher frequency. Those waves are going to appear squished. There are more of them per second. So that is something you're going to see on here as well, just making sure you can identify what something sounds like by looking at the wave or by reading a description of the wave. Let's see, what else is on here? Make sure you know the parts of the waves, both transverse and longitudinal. Make sure you know compression, rarefaction. Make sure you know crest and trough. With your standing waves, make sure you know nodes and antinodes. Make sure you can identify a wavelength of both a transverse and a longitudinal wave. Let's see. There's some math on here. Oh, proportional reasoning. If I ask you, if I double the frequency, what happens to wavelength? Again, you need to be able to understand the relationship between these two variables, frequency and wavelength. They are inversely proportional, okay? Because again, your velocity is determined by your medium, so this is basically a constant for any given scenario. So if you were to double this, this would be half. If this was quartered, this would be 4 times as much. So again, it's just an inversely proportional relationship between those two variables. So make sure you can answer questions about that. The last thing is about diffraction. And again, the amount of diffraction is going to be determined by, and the amount of diffraction that you have is going to be determined by the size of the opening. If you have a bigger gap versus a smaller one, you're going to have more diffraction here than you would here. You're going to have a lot less noticeable diffraction. So you're going to have more curvature of those waves over here. The other thing is wavelength. If the waves entering have a longer wavelength, your diffraction is going to be more noticeable if you have a longer wavelength than with a shorter one. So this would diffract more than this as well. So again, those are the different factors that affect the amount of diffraction you see. And then law of reflection, angle of incidence equals angle of reflection. Otherwise, all of the other concepts are pretty much already covered on this quiz. So again, just review that. You can use the booklet for additional review. You have a unit summary as well. There is an answer key posted. Make sure you're looking at those things as you prepare for your test.